Welcome to part 3 of our video on joints. We were talking about plantar flexion versus dorsiflexion. Now, in dorsiflexion, this is your dorsal region right here. So dorsiflexion, you are flexing that region like that. That angle is getting smaller. Now, your plantar region is down here. So in plantar flexion, that angle down there is getting smaller. So it's allegedly flexion. I've never bought it. And you're on your tippy toes. So again, if you watch Dancing with the Stars or whatever dancing show is on now, you'll see that all the good turners are plantar flexing and turning on the tips of their toes. Foot, this is plantar flexion. I'm pointing my toe. This is dorsiflexion, pulling back. And dorsiflexion, lifting the foot so it is superior first surface is approaching the shin. Plantar flexion, you are pointing your foot. The last two are retraction and protraction. And retraction. Now we have Yorick's skull here. He's going to help us show this. Protraction is to move a body part to the anterior. So you're sticking your chin out. So you have Yorick's skull. Oops, I just stuck my hand in your eyes. Protraction, you are sticking your jaw out like so. Retraction, you are drawing it back. So let's look at this big. In protraction, Yorick's jaw is coming out. In retraction, it is going to the posterior. Now, this is very important for the scapula. When you retract your scapula, you're bringing the outside, the lateral borders together. Your scapulae are going backwards. To protract, your scapula move forward. So there's a muscle that says retract and protract scapula, and it's very confusing because it's doing the opposite of what you'd think. Retraction just means it goes to the posterior. So we're going to look at the different synovial joints now. There's 6 types. And I'm going to repeat the actions when we talk about the different joints, instead of going over every single one individually. You're going to be able to define each type of synovial joint, including its action and its range of motion, and identify where they are. So, all synovial joints are diarthroses. That means they can move in multiple directions. And there's 6 types. What does planar mean? I already talked about planar. What about hinge? Oops, too far. What's a hinge? A hinge opens like a door. Ooh, so we have a wall right here, and we have the door, and it opens like so. What about a pivot? Where did I talk about the pivots? That's right, I talked about them right here. We have the dens, and we have the atlas being able to pivot around it. Condyle, I was mentioning these in the hand. Do you remember, what's a condyle? A condyle is a rounded structure, sort of like that. And in condylar joint, you have another concave structure. What sort of motion do you think that can do? Saddle. Ooh, is this the cowboy joint? I wonder what a saddle joint is. It must have something to do with a horse saddle, or they wouldn't call it saddle. And lastly, ball and socket. Nobody's ever... Guess what ball and socket is? That's right, you have a ball, and it goes into a socket, like so. So we're going to talk about these 6 types. So in a planar joint, 2 bones are going to slide back and forth in a plane. Now remember the acromion of the scapula. There's the scapula. And remember the acromial end of the clavicle. So what's going to happen is they're going to articulate. And it can slide like this. It can slide like this. So from our side view, it can slide like this. It could slide like this. So that is a planar joint. Our front view. It can slide like this. It can slide like this. Probably not the best front view. So it's going to have gliding motion. So sometimes these are called gliding joints. It can slide back and forth. In planar joints, you have a gliding action. So see how these 2 bones here, you have 2 flat bones and they are gliding in various directions. Now you have them between the intercarpals, or it's between the carpal, so it's the intercarpal joint, or in between the tarsals. The carpal metacarpal and tarsal metatarsal joint. The scapular clavicular joint. And this is going to have a bonus disc. Your vertebral costal joints. So remember, you have these transverse facets on the the thoracic vertebrae. There's your transverse facet. And you have the tubercle of the rib that can go up, down, left, right. The sacroiliac joint. Remember our auricular surface right there? And the sacrum has the same one. This joint can slide sort of like this, sort of like this. However, there's 50 zillion ligaments holding them together, so you don't really have that much give there. Proximal tibia, the condyles of the tibia, right here. So we have two condyles, and we have the head of the fibula on the, do you remember which one? The lateral one. And this will have some give. It can do a little bit of sliding, like so. It's a hinge joint. And in a hinge joint, you are going to have a cylindrical piece of one bone that is going to have another bone rotating around it, but only in one plane. When we get to the saddle joint, it'll be multiple planes. So remember, I kept making a big stink about this in tibia and fibula. I mean, the humerus and the ulna. Here is our humerus. That is the trochleella, so that must be medial right there. That's the capitulum, that is lateral. And the ulna likes to tell everybody, U is for ulna. We have the nice U-shaped trochlear notch. So the trochlea fits in nicely, and it is going to flex, that we're reducing the angle, and extend, we are increasing angle. Flex, extend. Notice I'm not talking about the capitulum and the head of the radius. That's technically a ball and socket joint. It's a weird one, but it is. Elbow joint, so you can flex and extend. So this angle is getting smaller. Now when the arm flexes, it goes to the anterior. Now the knee, the condyles are facing the opposite direction. So when it flexes, that is flexing. This is the angle back here that is getting smaller. So when the knee flexes, it goes to the posterior, then extension. So your arm, your knee, and your elbow are basically joints that are put together backwards. Now the interphalangeal joint is a hinge joint, so flex, extend, flex, extend, flex, extend. And technically your ankle, that's a modified one because it could have an eversion and inversion. Remember, inversion goes inwards, eversion goes outwards. And because of this, the movement is typically flexing or extend. Now there's a special joint, the temporal mandibular joint. What makes this joint special is it is a hinge joint, but there's a band of fibrocartilage right there. Remember, the articular discs are fibrocartilage. So we have the condyle right here going into the mandibular fossa, but there's a band of fibrocartilage. And this lets your jaw move around more. So we have Yorick's skull again, and because it's a hinge joint, its main action is to open and shut. Now, because it's going downward, this is depression and elevation. Depression and elevation. Most of the other ones are going to flex and extend. Because of that fibrocartilage, this is supposed to be the fibrocartilage disc. It can also protract and retract, and actually has some side-to-side motion as well. So this helps you grind your teeth up. Or not grind your teeth, but grind your food up with your teeth. So the temporal mandibular joint is special because of this meniscus, which is an articular disc, and it's made out of fibrocartilage. So you need to know that an articular disc is a meniscus, and it's made out of fibrocartilage. So the lower portion is a hinge joint, but it can have additional actions. It's a planar portion, so that is why you're able to protract and retract. And you have side-to-side motion as well, so it's a gliding joint up there. So our knee. Our knee also has discs. So these are discs right here called menisces, and they help the two condyles to fit together, because we have a rounded condyle here, fitting a rounded condyle here. So those are menisces. And those two are made out of fibrocartilage. Am I going to ask you what the menisces are made out of? Probably, since I've repeated it twice now. The next joint type is a pivot joint. So you could see hopefully this animation of the dowel going or pivoting around here. So in a pivot joint, we have the head of the ulna and the ulnar notch of the radius. So the radius can pivot around the ulna. So again, remember there's pivot motions that happens at pivot joints. At the proximal end, you have it too. It's not, since they're hiding it, it's sort of harder to see, but the ulna and the radius are pivoting. The head of the radius is pivoting in the radial notch of the ulna. The other place you have this is the dens and the atlas. So the dens of the axis sticks up where the body of the atlas would have been, and you have a pivoting motion, so you could shake your head no. Rounded surface of one bone articulates with a ring formed by a second. So the proximal and distal radial ulnar joints, it allows you to pronate and supinate. So again, pronation, I am starting with my hand down. My hand is up, so I could carry a clavicle or sup. Pronation, you're starting with your hand up, you're ending up with it down. Our next joint is a condylar joint. If you remember, a condyle has a rounded portion, and it's oval. So here we actually have the hand. This is not a condyle. That's actually the scaphoid bone. Now, if we see, it gets continued to lunate. Remember, I keep thinking your book is wrong, even though I tell students the book is always right. So we have a rounded surface. Now, if you look at this side of the radius, you have a concave indentation. So in a condylar joint, what's going to happen is you have the indentation fitting around the condyle shape, even though that's the scaphoid. So in anatomical position, I can flex, I could extend, I could hyperextend. Flex, extend, hyperextend. I can abduct, I can adduct. So I can flex and extend, I can abduct, and I could adduct. Here's my hand, flex, extend, adduct, going in, abduct. These are condylar joints here between the phalanges and the metacarpals. Flex, extend, abduct, adduct. In a condylar joint, you have an oval shape. So here's the oval shape right here. And it's fitting into a concave portion, so it can move in multiple directions. So it's biaxial. You can flex and extend, abduct and adduct. Saddle joint's the one that I always have the hardest time explaining. We basically have a saddle-like structure like this, and we have a cowboy or cowgirl with their legs sitting on it. So there they are. Now, you can actually have multiple rotations because of the shape. So you see the animation, how it can move multiple ways, and both bones can move. The bottom and the top bone are free to move. So it's actually a very movable joint, which means it's not a very stable joint. So there's a saddle-like structure right here. I don't know how well the light is. And the sternal end was going to fit in like so. This is actually this one. So this joint can move like this, or this can move like this. So it allows for rotation at both ends, or movement at both ends. So this is a saddle joint. The other saddle joint is between your first metacarpal right there, and the trapezium. So I can move my thumb in all sorts of directions to play video games. We have our trapezium right here, and we have our metacarpal. And you can sort of see there's a saddle-like projection going up like this, and that other bone actually looks like a saddle on the trapezium as well. So this allows you for grasping things. Trapezium, and we have the metacarpal fitting in, so it could go like this, it can move in multiple directions. So that's all the time we have. I guess I will talk about the ball and socket joints in the next video. Thank you very much. Have a good day.